Hello everyone, welcome back to Diksha Karnataka YouTube channel, and today I am going to bring you a very important part of your second PU final exam, that is all the 2 and 3 marker questions from physics that we will be going to discuss in this single video. If you watch this video, a lot of helpful questions you can answer. We are going to discuss in total almost about 65 questions, including all the chapters, everything. So one video for all the chapters. So if you watch this video, all of your 2 marker 3 marker problems will be solved. Okay, and we are not going to solve many numerical questions from this section. Only 2 particular numerical problems we are going to solve, which has a very high chance of coming to your exam. Other than that, we are not going to solve any numerical questions. So if you are someone who is having trouble with numerical questions, then you have to watch this video. Now let us start with the initial paper distribution. How many questions are there? So here we have total number of questions. There is some mistake over here. So total number of question in 3 marker section is basically 8. So out of the 8 questions, total number of questions that you have to answer given is 8. Out of the 8 questions, you have to answer 5 questions. So the numbers allotted in this section is 10 marks here. This will be 10 marks, and in the 3 marker section again 8 questions will be given to you. Out of that, 5 questions you have to answer, and total marks that you can score from this section is 15. So if you watch this video, 10 plus 15, 25 marks will be in your pocket. Okay, so if you are struggling with your physics, then definitely you have to watch this entire 65 questions that I am going to discuss. You can watch it in 2x speed. You can watch it at slower speed also, but at least watch it minimum 2 times you have to watch it, so that all of your questions are done. We are going to discuss this chapter wise, one by one. Okay, I will not mention the chapter, but we will do it one by one, and 2 marker 3 marker questions are all mixed through this. There is no separation between 2 marker and 3 marker. Some questions can come as 2 marker question, also can come as 3 marker question. Similarly, a 3 marker question can be asked as a 2 marker question as well. So for 3 marker they will ask you to mention 3 points, for 2 marker they will ask you to mention 2 points. That is the basic difference. Other than that, there is no such difference between these 2 questions. So we will mention where we are doing 2 marker, where we are doing 3 marker. So based on that we will see that. Okay, so state and explain Gauss law of electrostatics. Okay, so Gauss law states that, so this is a 2 marker question. Usually a 2 marker question comes from this part, and this can come as a prelude to any one of the 5 marker questions. So we have solved some 5 marker derivation as well. In the before asking the 5 marker question, they might ask that state and explain Gauss law in electrostatics. Okay, then they might ask using Gauss law prove this. So that is why also this is important. Explanation will not be there. Other than that, explanation part is basically for a 3 marker question. If they only ask you state Gauss law, state and explain, then it will generally be a 3 marker question, but only statement is basically a 2 marker question. Gauss law states that the total electric flux passing through a closed surface is equal to 1 by epsilon times the net charge enclosed by the closed surface, and explanation is phi is basically q by epsilon naught, that is E dot ds equals to q by epsilon naught. Q is the total charge enclosed by the surface S. You have to show one surface over here, and you have to show some charge enclosed here, Q. Okay, so this is the diagram that you have to draw in this case. Now next question, write Coulomb's law in vector form, explain the terms, and state and explain Coulomb's law. So both questions can come vector form or statement. Okay, vector form usually comes as a 3 marker question. Normal Coulomb's law is generally a 2 marker question. Let's see the statement. Coulomb's law states that the electrostatic force between 2 point charges is directly proportional to the product of the magnitude of the 2 charges and inversely proportional to the square of the distance between them. Coulomb's law in vector form is written by F vector equals to 1 by 4 pi epsilon naught q1 q2 by r square r cap. You have to draw a diagram like that, and then you have to show this is r cap direction. Okay, there is another diagram given in your textbook, and the formula and the values given in the textbook is slightly different. That is also acceptable, but if you write in this case, you have to write it this way, and you have to mention what are all the terms. If they don't ask you about vector form, then you can add the normal form, that is f equals to 1 by 4 pi epsilon naught q1 q2 by r square. This is also acceptable, but that is for normal Coulomb's law. If they ask you in vector form, then you have to write in vector form, and you have to explain these terms. Q1 and Q2 are point charges. Unit vector along the line joining the charges. So you have to mention that. Okay, so to stay in the safe side, you have to mention what is r cap is, what is q1 q2, what is epsilon naught, and what is r. Obviously from the diagram it is clear. The simple diagram you have to draw as well. Right, statement I am not going to elaborate it, because you already know the statement. It is proportional to the product of the charges, inversely proportional to the square of the distance, and in vector form this is the form. Now next question. Sketch the electric field lines of force due to a point charge q if q is less than 0, q is greater than 0. So these are the diagrams. Q less than 0 means negative charge. Okay, so in this case the diagram looks like this. All the lines are coming towards the charge, and for q greater than 0, all the field lines are going out of the charge. So these are the two diagrams, very simple, easy diagrams you have to draw. So just remember, less than 0 means negative charge, greater than 0 means positive charge. That's it. Okay, easy question, but still this is from one of your model question paper, so don't ignore this question. Next is define the electric dipole moment, mention its SI unit. So an electric dipole is a pair of equal and opposite charges q and minus q separated by some distance 2a. Its dipole moment vector p has magnitude 2qa and is in the direction of the dipole axis from minus q to plus q. Its SI unit is coulomb meter. In this case you have to draw an accompanying diagram. So two charges separated by a small distance, so plus q and minus q separated by a distance 2a, and the dipole moment is from negative to positive. So this is the dipole moment. Okay, so this diagram has to be accompanying with this answer. Okay, now the charges are additive in nature. Explain. This is also one from your model question paper. If a system contains 2 point charges q1 and q2, the total charge of the system is obtained simply by adding algebraically q1 q2. That is, charges add up like a real numbers, or they are scalars like the mass of a body. The total charge of a system containing 5 charges plus 1 plus 2 minus 3 plus 4 and minus 5 in some arbitrary unit is basically, you just add them algebraically and you get the answer minus 1 in the same unit. Okay, so basically charge are scalar quantity. That is what you have to explain, and after explaining you have to give one example, which is very, very compulsory. So this is one of the properties of charge. So if they ask you properties of charge, then definitely you can add mention charges are additive, but if they ask you elaborate additive nature of charges, then you have to mention everything on this. Okay, derive an expression for the torque on a electric dipole placed in an uniform electric field. So we have a uniform dipole placed in an uniform electric field. Now what are the forces acting on this dipole? So first of all, this positive charge will experience a force in this direction, right, in the direction of electric field. Positive charges always experience force in the direction of the electric field. So let's say this force is F plus. Okay, and the negative charge will experience an equal and opposite force in the opposite direction, F minus. Okay, so what is the magnitude wise F plus equals to F minus? What is that value? Say F. Magnitude wise, direction are opposite. Now what is the value of F? value of F is basically what is the electric field, E, what is any of the charges, Q. So value of the force is Q into E, right? This is the force. Now what we are trying to find, we are trying to find the torque acting on this. So to find the torque, what you have to do, you have to draw like a line like this, and then you have to join this. Okay, so this is the distance. So if the distance between the dipole is A plus A, that is 2A, total distance is 2A. Okay, so what is this distance? To find this distance, we need to know this angle theta. If we know this angle theta, this will be the same angle, parallel line, right? Parallel line means this is the bisector, so they are similar angles, so they will be same. So this is theta. Okay, this distance is 2A. Then what is this distance? So this will be, if you see this angle, with respect to this angle, this is the perpendicular. So perpendicular by hypotenuse. So say this is the perpendicular, say L, distance L. So perpendicular by hypotenuse, that is 2A, is basically sine theta. So L equals to 2A sine theta. Now what is the torque? Torque is basically force into the distance between the charges. Now we just distance between the forces, distance between the forces. For now we are just using the scalar form. We will apply the vector form once we arrived at this. So F into L is the, so any one of the forces times the distance between the forces is the torque. That you have studied in your PU1. I know many of you have forgotten, so you have to remember that force, one of the force times the distance between the force, right? So torque or couple is basically when two equal and opposite forces acting on an object, but they have different action of line. Then any magnitude of any one of the force times the distance between the force gives you the torque. This is FL. F is what? F is Q into E. And what is L? L is 2A sine theta. Or let us organize. Now we have arrived our final, almost final expression, 2A into Q sine theta. Now what is 2A into Q? 2A into Q is the dipole moment. So P into E sine theta. Now what is the vector form? In vector form we can write this as torque equals to P cross E, because sine theta is basically comes in vector product. Also torque is a vector quantity, P is also vector quantity. So this is the expression for torque acting on a dipole. Very easy derivation. Okay, 3 mark derivation. If you do the derivation, you can get 3 marks. Very commonly asked and easy also, not super hard. Write any 3 properties of electric charge. The most common question every student is waiting for. What are those? Additivity of the charges. Charges are additive in nature. Explanation we have seen there. Quantization of charges. All charges are integral multiple of smallest charge E. Conservation of charges. Total charges in isolated system is conserved. Very, very important, isolated system. Okay, based on that, in fact, we have seen some objective 1 mark question as well. Now question number 8, write 3 properties of electric field lines. Another question students are most waited for. Electric field lines may start from positive charge and end at the negative charge. 2 electric field lines never intersect each other. The favorite property of field lines for all the students. In fact, same thing you can use for the magnetic field lines as well. Electrostatic field lines do not form any closed loop. Okay, this is also, all 3 are very common. So this is also can come as a 2 marker question as well. Only 2 points you have to mention in that case, but it can come as a 3 marker as well. So you have to memorize at least 3 points. Now what is an equipotential surface? What will be the shape of the equipotential surface corresponding to a single point charge? Any surface which has same electrical potential at every point is called an equipotential surface. The shape of the equipotential surface is spherical for a single point charge. For a single point charge, you have to draw a sphere like this. Okay, so single point charge, this is a sphere. 3-dimensional, 2-dimensional is a circle, 3-dimensional this is a sphere. So that is why the shape of the equipotential surface is sphere. On what factor does the capacitance of a parallel plate capacitor depends? To answer this question, what you have to do? First you have to mention, we know that capacitance is basically A epsilon naught by D. Now there is obviously for a normal capacitor we can also add dielectric constant A epsilon naught by D. Okay, so from there we can see that C is proportional to A, that is directly proportional to the area of the capacitor plates. Right. Similarly, C is inversely proportional to the to D, that is it is inversely proportional to the distance between the plates. Okay, so it is inversely proportional to the distance between the plates, directly proportional to the capacitance, and you remember third point is basically it is proportional to the dielectric constant between the plates. Okay, in case this same question asks as a 3 marker, in that case you have to remember that as well. Now write two properties of equipotential surface. Again another important question. I give you 3 points because it can come as a 3 marker as well. No work is done in moving a test charge over an equipotential surface. So in the equipotential surface, if you move a test charge, there is no work done. Electric field is always normal to the equipotential surface at every point. No two equipotential surface can intersect each other. Similar to that of electric field lines, equipotential surfaces also do not intersect. Now next part is obtain the expression for effective capacitance of two capacitors connected in series. So we have series combination of capacitor are important because slightly difficult, parallel one is easy, right? Series combination of capacitors. We have two capacitors of potential V. This is C1, C2. The charge that is flowing is Q. Okay, now potential drop across this is V1, potential drop across this is V2. Okay, so these are the things that we know. So what we have to do, we have to find the equivalent capacitance. What is the equivalent circuit looks like? Always remember, equivalent circuit has only one capacitor. No matter what is the combination, equivalent circuit will always have one capacitor, one battery. Okay, the total charge in the circuit will remain same. Okay, that is the basic part. Now if we apply normal law, that is Q equals to CV1. Okay, that is V1 equals to Q by C. Similarly, this is for capacitor 1. Similarly, for capacitor 2, we can write V2 equals to Q by C2. Okay, so what is the total voltage? Total voltage is V1 plus V2. So just add them, Q by C1 plus Q by C2. Now form the equivalent circuit. From equivalent circuit, that is for equivalent circuit, okay, Q equals to C equivalent into V. Q is equal to CV. Basically we are applying the same thing 2-3 times, that's it. So Q by C equivalent. So this is our equation 1, this is equation 2. Now comparing, now what we have to do, we have to compare equation 1 and 2. So comparing 1 and 2, what do we get? We get Q by C equivalent is equal to Q by C1 plus Q by C2, or that gives you 1 by C equivalent is basically 1 by C1 plus 1 by C2. Okay, this is the equation. So obviously you arrived at the relation. This is the required relationship. Now let's move on to the next part. Give 3 results of the electrostatics of conductors. Again, inside a conductor, electric field is 0. Always remember that it is sometimes used in electrostatic shielding. At the surface of the charged conductor, the electric field must be normal to the surface. Electric field, there is this M is extra. Electric field must be normal to the surface of the every point. The interior of conductor can have no excess charge in the static situation. This is called electrostatic shielding. Okay, combining these two properties is basically we use it to protect high maintenance equipment, right? That is the uses of electrostatic shielding. Now next, derive the relationship between electric field and electric potential due to a point charge. So let's see, we have to consider 2 equipotential surfaces. One surface is A, one surface is B. Now electric field always points from higher potential to lower potential. So this surface has a potential V, this surface has a potential V minus dV. Okay, do not use delta B. I have taken this diagram from one of your textbooks, so that is why they have using this delta V. We are delta V, but we know already the differentiation, so we will use dV. Okay, so this is the direction. Now what is the work done to move a charge from, say, a charge Q? What will be the work done to move the charge Q from this surface to this surface? Okay, that is our point of observation, and we will find this work done in 2 ways. One is using electric field, one is using electric potential, and then we will compare them. Okay, so at this point the electric field is E. So what is the force, electric force acting on this charge? So the force acting on this charge is basically Q into E. Okay, the distance between these two planes is basically dl. The distance between these two planes is dl. So what is the work done? Mechanical work done. From the definition of mechanics, we know that the work done is basically given by force acting into the displacement, that is dl. Right? So what is the force? Q into E into dl. Now this is the mechanical work done from mechanical principle. Now from the definition of potential, from potential definition, work done is basically the potential difference, that is the final potential, V minus dV minus V into the charge. This is the potential definition, that potential difference times the charge. So potential difference is final minus initial, so that will be V cancels, so you get minus dV into Q. Now these two work done must be equal. Even though we have got them from 2 different sources, work done for moving a single charge cannot have different values, so definitely they will be equal. Now Q cancels, so E becomes minus dV by dl. The negative sign indicates that electric field points where the electric potential is decreasing. Okay, so negative sign indicates that electric field is higher at higher potential. Okay, that is fine, but electric field always points towards the decreasing potential. So if this arrow is in this side, that means potential where it started will be higher and potential where it ends will be lower. Okay, based on this concept, lot of KCET question comes. Which point has the highest potential? A, B, C. So always remember that this is the point which is pointing towards the electric field, so this point will have highest potential. Okay, so this is a small KCET question, comes in the exam. Okay, not in this exam, not in your PU board exam, but just for your reference I just discussed it. write the expression for dip velocity in terms of current, explain the terms used. Okay, so let's see. Current is basically given by I is equal to NEA VD. So VD is basically I by NEA. I is current, N is number density of electrons, E is the charge of an electron, and A is the area. Now let's move on to the next part, next question. Define drift velocity and mobility of free electrons in conductors, or sometimes only define mobility, mention is SI unit. This is also a possible question. 2 marker, both of them are 2 marker questions. So let's see. Drift velocity, the average velocity with which the free electrons drift under the influence of an electric field is called drift velocity. So drift velocity is obviously when it is moving in the influence of the external electric field. Okay, our mobility is the free electrons is the defined as the drift velocity of electron per unit electric field applied. So mobility is basically drift velocity per applied electric field. Okay, so this is basically how quickly an electron can move within a given electric field, right? So SI unit of electron mobility is m square s to the power minus 1 volt to the power minus 1, or m s to the power minus 1 Newton inverse coulomb. So as you can see, the unit is not simple. You have to remember the unit. Okay, you have to remember the unit. Or what you can do that VD by E, right? What is VD? VD is meter per second, and what is E is Newton per coulomb. So if you do that, you will get meter coulomb, okay, divided by Newton second. That is meter coulomb Newton inverse second inverse. This is the another way to remember. How can you find the unit? Okay, this is one way. This is also another way. Here we have mentioned the electric field unit in volt per meter, so that is another way to write the unit. Okay, anyway, you can remember the unit. I told you the trick how to remember. Now next question, mention 2 limitations of Ohm's law. So what are the limitations? Ohm's law is applicable only if all the physical conditions remain same. Okay, physical condition means physical state, temperature, etc. Not temperature, physical state. It should not change the state. Okay, so that is what is main thing. Ohm's law is not applicable at very low and very high temperature. So Ohm's law cannot be applied very high or very low temperature. Ohm's law is not applicable to non-ohmic devices like semiconductor devices, discharge tubes. They are specifically some kind of materials where I and V is not unique. I versus V graph is not unique. Okay, for single I you can have multiple V's. Similarly, for a single V you can have multiple I's. So that's why they are called non-ohmic conductors, and Ohm's law is not applicable to them. Now give any 2 differences between current and current density. So current is defined as the amount of flow of electric charge per unit time. Unit of current is ampere. Current density is basically the current density is the amount of current per unit area. So current is obviously I equals to, you remember, Q by T. Current density is J equals to I by A. If you remember this, you are done for. Okay, you can answer this question. So the current is charge per unit time, current density is current per unit area. Its SI unit is ampere, its SI unit is ampere per meter square. This is based on this, and 1 marker question also came in last year. So this is also important. Now question number 19, name 2 factors on which the resistivity of a wire depends. So obviously resistivity depends on material of the wire, temperature of the wire. Okay, so this is, we are talking about resistivity. Now if the same question comes about resistance, so just gives you an heads up, resistance, same question can come about resistance as well. Now resistance is basically, we know that rho L by A. Okay, so obviously resistivity for a given material is constant. Now in that case, resistance is directly proportional to length, and resistance is directly proportional to inversely proportional to area. based on this also sometime comes, what is the on what factor resistance of a conductor depends. So that is also a very important concept. Now let's see question number 20. When does a current carrying conductor placed in an uniform magnetic field experiences maximum force and minimum force? So what is the, first of all we have to find what is the force experienced by a current carrying conductor in an uniform magnetic field. So the force experienced by a uniform magnetic field is basically BIL sin theta. Don't confuse with force acting on a charged particle. Here force acting on a current carrying conductor. So this is the expression for force on a current carrying conductor. Now this can also be written as I into L cross B. Okay, the sin theta basically comes from the fact it is L cross B, right? Now if basically what is the meaning of this is the force in vector form. Okay, now what is the meaning of that? If theta is 0, then there is no force acting. So and maximum is when theta is 90. So if the theta is 90 degrees, that is current is flowing perpendicular to the magnetic field, the force is maximum, right? And if theta is 0, this is the first case. The second case is minimum. When theta is 0, current is parallel to the magnetic field, the force is 0, that is minimum. Okay, so force is 0 when they are in the parallel direction. So if the current is flowing in this direction, magnetic field is also in this direction, then force will be 0. If current is in this direction, so this is I, this is B. Now current is in this direction, magnetic field is in this direction, so in that case force is maximum. Okay, simple equation. You can remember either first one or second one. You can write any one of the equation. You don't need to write both the equations. Any one is sufficient. Now next question. Write the expression for magnetic force per unit length between two straight parallel conductors carrying current. Give the nature of the force between two parallel conductors carrying current in the same direction. Okay, so let's see. So FB, that is the force per unit length, is given by mu naught 2 pi Ia Ib by d. You have to draw a small diagram here. So you have to draw a small diagram. This is say A, wire A carrying a current Ia. This is wire B carrying a current Ib. The distance between them is d. If you draw this small diagram, very small short diagram, if you draw it, you don't have to do anything else. This is self-sufficient, self-explanatory, right? And Ib and Ia is through the current through the wires, d Ia comma Ib. Okay, and d is the distance between the wires. Parallel currents attract, anti-parallel currents repel. So they are only talking about current carrying in the same direction. So if the current is in the same direction, they will attract each other. Okay, if current in the same direction, they will attract each other. If the current in the opposite direction, then they repel each other. So in the question they have said same direction, but in the exam they said in the opposite direction. Then you will say, sir, you have not explained what will happen to the opposite direction. So I gave you both parts. If same direction they attract, if they are opposite direction they repel. Now, next question. Derive an expression for angular frequency of revolution for a charged particle moving perpendicular to a uniform magnetic field. Or there is a or question, similar question. Obtain an expression for the radius of circular path taken by a charged particle moving perpendicular to a uniform magnetic field. So either angular frequency omega or radius r, the process is same, the method is same. So first of all we have to start with magnetic force. Fb equals to mv square by r. Okay, so this is the magnetic force is basically providing the required centripetal force for the circular motion. Now what is the magnetic force? Magnetic force is QVB. Now they are perpendicular, so the term is 0. QVB sin theta is 90 degree, so that part is 1, not 0, sorry. So mv square by r. Okay, so v, one of the v's cancels. First we will find the or question, that is r, radius of the circular motion. So r will come here, r equals to m into v, 1 m and 1 v is still left, and qb goes down, qb. This is the first expression. This is the expression for the radius of the circular path. Now this is not over. If they ask you to find the angular velocity or angular frequency, that is omega, how to do that? So for that, what you have to do, you have to find v. Up to this much is common. Now what is v? V is equals to q b r divided by m. We are trying to find this v. So QB, this R goes up and divided by M. So QBR by M. Now what is omega? So in rotational motion we know that V equals to R omega, right? This is the relationship, we just need to put that here. So V equals to R omega, so that is QB R by M. R cancels, so omega equals to QB by M. Okay, so this is the angular frequency. Now if they ask you what is the frequency of rotation, only frequency of rotation, then you should know that omega is equal to 2 pi nu. Nu is the frequency, or 2 pi f for the fact. That is equals to qb by m, or nu equals to 1 by 2 pi qb by m. This is sometimes called cyclotron frequency. Even though the cyclotron is not there, this expression for frequency might come. So all three possible derivations from this question we have done in one go. Now question number 23. What is Lorentz force? Write its expression and explain the terms. So Lorentz force is basically, there are two types of force. When a charged particle moves through an electric and magnetic field, okay, it experiences a force that is called Lorentz force. The text I have not written, you have to write it down. It is very easy. So when a charged particle moving through a electric and magnetic field, it experiences a force which is called Lorentz force. Now what are the forces acting on it? There are two forces. One is electric force. So say electric field is E, okay, then the force, electric force is Q into E, okay, vectorially. Remember, when you are talking about Lorentz force, you have to show the vectors, and the magnetic force is basically given by Q into V cross B. So the expression is, the Lorentz force FL, say, is basically FE plus FB. That is equals to QE plus QV cross B. Now take Q common, you will get E plus V cross B. This is the expression for Lorentz force. Okay. How can a galvanometer be converted into a voltmeter? Explain with the diagram. So first, galvanometer can be converted into a voltmeter by connecting a suitable high resistance in series with it. So what is the diagram? We have a galvanometer. We have to connect a high resistance value with it. So this is called very high value. Okay. So this is the whatever current is passing through this, okay, the voltage across this will give you that maximum current will be the current through the galvanometer, right? Maximum current through the galvanometer. So what is the measured voltage? Maximum measured voltage is basically R plus G into Ig. Simple equation, just mention it, you will get full marks. Okay, now what is the next part? How can a galvanometer be converted into an ammeter? Explain with a diagram. So a galvanometer can be converted into an ammeter by connecting a suitable low resistance S in parallel called shunt with it. So this is slightly tricky. Here we have a galvanometer, okay, and we applied a shunt to it. Okay, say this shunt is S. Now we have an external current which is I passing through this. We are trying to measure this I, but galvanometer can maximum have the current limit, that is Ig. Remaining current will pass through the shunt resistance I minus Ig. Okay, so what is the meaning of that? Now voltage, they are connected in parallel, so voltage drop across both of them will be same. So Ig into G equals to I minus Ig into S. Now we have to find this value of S. So S equals to Ig into G divided by I minus Ig. As simple as that. G and Ig are generally known, and I is the maximum value of current that we can measure using this corresponding value. So based on the maximum value of I, we are trying to measure, S value will vary. So this is how the expression looks like. This is very simple common expression, and you have to show this expression exactly like this. Next is 26. State Ampere's circuital law and arrive at the expression for the magnetic field due to a long straight current carrying wire. Okay, so Ampere's circuital law states that current through any closed loop is basically whatever is the magnetic field, that is B dot dl is basically mu naught I. So if the magnetic field due to some current carrying element is B at some point on a path, then if you take the path integration B dot dl, you get mu naught I enclosed. It is similar to that of the Gauss's law. In Gauss's law, it talks about electric field. In Ampere's circuital law, it talks about the magnetic field. Right? Now we have to consider a straight wire. Now in this case, we have to consider a circular Amperean loop. Now Amperean loop can be anything. It sometimes can be a square. It sometimes can be circle. Okay, but this is easier. Now we are trying to find. This is a current carrying loop. We are trying to find the magnetic field at this point at a distance r from it. So simple Ampere's circuital law will apply. B dot dl equals to mu naught I. Now B and dl are corresponding, they are parallel to each other. So if this is B, the magnetic field will be in this direction. Okay, so the angle will be B and dl's angle will not be in the same direction, not be 90 degrees. So B dot dl will not be 0, but B will be constant along the circle. B will be constant along the circle, so B can come out of the integration, right, because constant does not do any integration. Now what is dl? Dl's are basically small parts. So integration dl is basically adding all the small dl's, right? So integration dl is basically means the perimeter of the circle. Okay, so if it is ds, area, if it is dl, it is the perimeter. Okay, so what is the perimeter of a circle? Perimeter of a circle is 2 pi r, so it is equals to mu naught I. So B is basically equals to mu naught by 2 pi into I by r. Okay, this is the expression that they have asked you. For stating the Ampere's circuital law, you get 1 mark. For doing the derivation, you get 2 marks. State and explain Biot-Savart's law with a suitable diagram. So Biot-Savart's law is like this. We have a current element dl, current I is passing through it, and we are trying to find the magnetic field at some distance due to this small element carrying current I is dB. Okay, at some point P. So what is this dB is about? dB is directly proportional. Number one, dB is directly proportional. The angle between the dl and this element distance vector is theta. So dB is directly proportional to the length of the current element dl. dB is directly proportional to the current passing through it, not the vector form, sorry. Vector form is possible, but we are not interested in vector form. Directly proportional to the current. Okay, number 3, it is directly proportional to the square of the distance between them, and fourthly, it is directly proportional to the sine of the angle. Okay, these are the 4 equations, and if you combine them, you get dB equals to I dl sine theta by r square. This is the combined statement of Biot-Savart's law. Give the principle of AC generator. Y is a current induced in an AC generator called alternating current. Mention the expression for induced EMF in it. So let's see. An AC generator converts mechanical energy into electrical energy by changing the flask linked with the rotating coil. The direction of the current produced in an AC generator changes periodically, and therefore the current is called alternating current AC. Now what is the expression for the induced EMF? So induced EMF is N number of turns, area, magnetic field associated with it, and omega. So NAB omega is the EMF induced in the AC generator. Okay, simple expression, NAB omega. Omega is the angular speed. If you increase the angular speed, more amount of EMF will be induced, right? So this is the expression. N is the number of turns. You have to explain the terms. N is number of turns, A is the area of the coil, and B is the magnetic field linked with the coil, and omega is the angular speed. Now state Faraday's law and Lenz's law of electromagnetic induction. Faraday's law: time rate of change of magnetic flux through a circuit induces EMF in it. The polarity of the induced EMF such that that tends to produce a current which opposes the change in the motion and that produced it. So epsilon is equal to minus d phi by dt. Okay, this is the simple expression. Now next, mention any 2 factors on which the self-inductance depends. So the equation for self-inductance is L equals to mu naught N square A into L. Here N is basically number of turns per unit length. So self-inductance is directly proportional to the square of the number of turns per unit length. Okay. Self-inductance is directly proportional to the cross-sectional area A of the solenoid. Self-inductance is directly proportional to the length of the coil. Okay, coil or solenoid, same thing. Okay, self-inductance depends on these 3 things. Also, mu naught, instead of mu naught, if you add any other material inside the coil, you will get a different self-inductance. So mu also changes the self-inductance. Next, derive the expression for the motional EMF induced in a straight conductor moving perpendicular to uniform magnetic field. So let's see. Here we have a wire. Now this wire is moving in this direction. The magnetic field is into the page of the paper. So we have to find the motional EMF for this. So first of all, what is the flux linked with this coil or this rectangular structure at this instant? So the flux linked with this is basically, what is flux? Flux is basically B into area A, right? So B is given. The magnetic field B is given for this case. So the magnetic field, say assume that magnetic field is B. But what is area? Area is this area. Okay, so at this distance, the distance between them is, at this point is x. So what is the formula for x? X is area. Area is basically distance into length. So flask will be B into x into L. Right, now L for this wire is constant. Okay, so what is the induced EMF? Induced EMF magnitude wise is basically magnitude of induced EMF is magnitude of induced EMF is basically d phi by dt. We are basically neglecting the negative sign here. That is the main thing. So now d phi of dt is ddt of bxl. Now B and L are constant, so they will come out of the differentiation. So B into L into dx by dt. What is dx by dt? Dx by dt is basically, if you remember in your first PUC, basically the velocity. So it is B L into V, or epsilon induced is B V L. Okay, some weird thing is happening. So BVL is the induced EMF in this case. Okay, this is very common derivation. If you do this way, that way I have shown you is very simple and easy. Now next, 32, describe an experiment to demonstrate the phenomena of electromagnetic induction using a bar magnet and a coil. This is also very common question. The diagram that you have to do is roughly like this, and what you have to write in here, very careful. When the magnet approaches the coil, the galvanometer needle deflects, indicating a current is induced. When the magnet is pulled away, the needle deflects in the opposite direction. This is must have this statement. You have to write, there is no other option. Okay, you have to write this statement. Okay, opposite direction, showing that the current reverses. No current is induced when the magnet is stationary and relative to the coil. So magnet is stationary means no current induced when the magnet is stationary. Very important. Conclusion, the experiment demonstrates the electromagnetic induction, a current induced in the coil when the magnetic flux through the coil changes. This confirms Faraday's law of induction, and the direction of the current flows follows the Lenz's law, opposing the change in the magnetic flux. Okay, easy. Now let's move on to question 33. Write any two uses of ultraviolet radiation. So ultraviolet radiation can be focused into very narrow beams for high precision applications such as LASIK. LASIK is eye operation. UV lamps are used to kill germs in water purifiers. Next, name the magnetic waves used for the following applications. Radar system used in aircraft navigation. The remote switches for household electronic devices. So radar system we use microwaves, and remote system we use infrared rays. So microwave is used for radar system and infrared rays are used for remote switches. There are few more applications, you can check that out in your textbook. Radio waves, okay, that based on that, if you read that chapter, it is very small chapter, it will take hardly 30 minutes to read that chapter, especially the application part, all the waves part. Okay, from that there might be one question coming. Now next, what is displacement current? Give the expression for it. So displacement current is the current due to changing electric field is called displacement current, and expression is ID equals to epsilon naught d phi e dt. Here phi is electric field. Okay, sorry, electric flask. Phi is electric flask. Okay. Now, what is electromagnetic waves? How they are produced? So oscillating electric field in space which produces oscillating magnetic field, which in turn is a source of oscillating electric field, and so on. The electromagnetic waves are produced by accelerating charges or oscillating charges. Okay, so electromagnetic waves are basically produced by oscillating charges. One oscillating charge will produce an oscillating magnetic field. The magnetic field in turn will produce another oscillating electric field. This oscillating electric field will produce another magnetic field. Now this will produce another electric field. Like that they keep on producing, and like that they keep on progressing. Okay, slightly complicated theory, but this is the easiest explanation of the theory. Next, mention any two uses of infrared rays. Electronic devices such as LEDs uses infrared rays and are widely used in the remote switches of household electronic systems such as TV sets. Infrared lamps are used in physical therapy as well, for heat therapy. Now next, write any three difference between diamagnetic, paramagnetic materials. Okay, very common. So diamagnet, paramagnet, and I think I will do paramagnet and ferromagnet, but there are possibility diamagnet and ferromagnet might also come. So you have to be prepared. You have to prepare these two tables, and based on this you can answer all the other tables. So first, diamagnetic and paramagnetic. So magnetic behavior, they are weakly repelled by a magnetic field. They are weakly attracted by a magnetic field. Magnetic susceptibility, have a small negative magnetic susceptibility, have a small positive magnetic susceptibility. Effect in magnetic field induces a magnetic moment in the opposite direction of the applied field, induces a magnetic moment in the same direction of the applied field. Now next question. So these are very common question. I am not going to explain. Mention 3 properties of magnetic field lines. Another common question, most students are waiting for this. Magnetic field lines of a magnet form continuous closed loops. Okay, the tangent to the field at a given point represents the direction of the net magnetic field at that point, and the magnetic field lines do not intersect, for if they did, the direction of the magnetic field would not be unique at the point of intersection. So another common question. Okay, question number 40, write the difference between diamagnetic and ferromagnetic material. So as I said, we'll be doing diamagnetic, ferromagnetic, diamagnetic and paramagnetic. Para and ferro are also very common. So in that case, you have to replace all these properties with the paramagnetic properties that we have learned in the first table. So magnetic behavior, they are weakly repelled, they are strongly attracted. Magnetic susceptibility, have a small negative magnetic susceptibility, have a large positive magnetic susceptibility. Effect in magnetic field induces a magnetic moment in the opposite direction of the applied field, induces a strong magnetic moment in the same direction as the applied field. Now question number 41, define magnetization of a sample. How is it related to magnetic intensity? So magnetization M of a sample is the measure of the net magnetic moment per unit volume of the material. Okay, so net magnetic moment divided by volume is the magnetic moment. Relationship with magnetic intensity is basically M is equal to chi into H. Here chi is called magnetic susceptibility. Okay, easy question. State and explain Gauss's law of magnetism. So Gauss's law of magnetism is the net magnetic flux through any closed surface is 0, that is B dot ds equals to 0. Physical significance, the magnetic monopoles do not exist, that is magnetic field lines always form closed loop. Now if you see, there is no physical significance is asked, but that might be asked as a 3-marker question. That is why I have added this part as well. Name the objective used in refracting type telescopes and reflecting type telescope. What is the objective used in reflecting type, refracting type? Convex lens, and obviously in refracting type it is concave mirror. Okay. Write the 2 conditions required for total internal reflection. Light must be travel from denser to rarer medium. The angle of incidence must be greater than that of the critical angle. Angle of incidence must be greater than the critical angle between the media. Okay, next question. How does the power of a lens varies with focal length? The power of the focal length is in meters and are inversely proportional. If focal length is f in meters, okay, f in meters, and power is in p in d. Power is p in d, that is diopter. Okay, then f p is equal to 1 by f diopter. This is the relationship. Okay, unit of power is diopter. Okay, so this is the answer. Now, next question. Mention 2-3 uses of application of Polaroids. 2 and 3. Obviously 2 means 2 marker, 3 means 3 marker. Okay, applications are same thing. Uses, applications, same thing. So Polaroids are used to control the intensity of sunglasses, window paints, etc. Polaroids are used to photographic cameras and 3D movie cameras. They are used in 3D movie glasses as well. Okay, if you have next time whenever you go to 3D theater, when the 3D movie is going on, try to remove your Polaroid and see your glasses and see what is happening on the screen. And then what you do, you cross one of your eye and see what you are seeing, and then the next eye, and you will see a different image. Okay, slightly different, slightly shifted. Okay, give the conditions for constructive and destructive interference of light in terms of path difference. So constructive condition is x equals to n lambda, where n equals to 0, plus minus 1, plus minus 2, and destructive interference x equals to n plus half lambda, where n equals to 0, plus minus 1, plus minus 2 again. Now Next question, what are the coherent sources of light? Give one example. Coherent sources of light are the light sources that emit light waves with the same frequency, wavelength and phase, or have a constant phase difference. Example is laser light. State Huygens principle in wave theory of light. So Huygens principle states that every point on a wavefront acts as a source of spherical wavelets. The sum of these wavelets form a new wavefront. So if you see, this is a source, this is the primary wavefront, and from there secondary wavelets are emanating, and they are giving rise to the previous wavefront and the forward wavefront. Both wavefront you can get it from this. So if this question is asked, this diagram is compulsory. Also just the statement comes if you in some of the 5 marker question as well. So if you see the same question in 5 marker as well, you have to write the statement only in that case. Give Einstein's explanation of photoelectric effect and write Einstein's photoelectric equation. So Einstein suggested that the photon of a light energy proportional to its frequency nu given by E is equal to h nu, where h is the Planck's constant. When light shines on a metal surface, photons transfer to their energy to the electrons in the metal. Any energy from the photon exceeding the work function becomes the kinetic energy of the ejected electron. Now the Einstein's photoelectric equation is kinetic energy is equals to h nu minus phi naught. Phi naught or phi, both function, sometimes also some people write it me v square equals to h nu minus h nu naught. Okay, these are all the functions. E v naught equals to h nu minus nu naught. All of these are Einstein's equation. You can write any of them. I prefer this one. This is the most fundamental equation. Okay, so any one of the equations you can write. Now give 3 results of experimental study to photoelectric effect. Sometimes the same question is asked as Holbach and Leonard's observation. So you don't need to worry. You have told us only about of experimental observation, but you didn't tell me about Holbach and Leonard observation. These are the same thing. But so what is the answer? For a given metal, no electrons are emitted if the frequency of the incident light is below a certain minimum value called the threshold frequency nu naught, regardless of the intensity of the light. Photoelectric emission occurs without any noticeable delay after the light strikes the surface, even for a very low intensities. Okay, the maximum kinetic energy of the emitted electrons increases linearly with the frequency of the incident light above the threshold frequency. These are the 3 very common points, easy to remember. Okay, maximum kinetic energy, threshold frequency. Okay, and then it is an instantaneous process. So these are the very 3 common observation. What is the meant by photoelectric effect? Defined work function, defined threshold frequency. The photoelectric effect refers to the phenomena where electrons are emitted from the surface of a metal when light of certain frequency or higher shines on it. These emitted electrons are called photoelectrons. The work function phi is the minimum energy required to eject an electron from the surface of the metal. It is a property of the metal and is typically measured in electron volts. The threshold frequency nu naught is the minimum frequency of the incident light required to cause the emission of the electrons from the surface of a metal. For light with frequency below nu naught, no electrons are emitted regardless of the light intensity. Mention Einstein's photoelectric equation and explain its symbol. Okay, so Einstein photoelectric emission, this is another equation that you can write. So h nu is equal to phi plus half mv square. Here m is the mass of the electron. Okay, Planck's constant is h. Nu is the frequency of the incident light. Work function of the metal is phi. Mass of the electron is half 9 into 10 to the power minus 31. The value you need not to write it. V is the velocity of the ejected electron. Okay, if you write this as h nu equals to phi plus k max, that is also fine. Okay, k max is the kinetic energy. Name the majority and the minority charge carriers in a n-type semiconductor. So majority charge are electron, minority are holes. So n-type semiconductor means negative type, obviously electrons. What is the intrinsic and extrinsic semiconductor? In the intrinsic semiconductor are the pure semiconductors, are called intrinsic semiconductors. The presence of charge carriers, electrons and holes is an intrinsic property of the material, and these are obtained as a result of thermal excitation. So intrinsic semiconductors are those which are pure semiconductors. Next, extrinsic semiconductors are those number of charge carriers can be changed by doping of a suitable impurity in pure semiconductors. Such as semiconductors are known as extrinsic semiconductors. There are two types of extrinsic semiconductors, p type and n type. How can a semiconductor diode be forward biased? What happens to the width of the depletion region when the forward bias voltage is increased? A semiconductor diode is forward biased when you connect the positive terminal of a power source like a battery to the p-type side and the negative terminal to the n-type side. This setup helps to overcome the potential barrier created in the depletion region and allows the current to flow through the diode. Okay, as you increase the forward bias voltage, the depletion region becomes narrower and slowly disappear. This is the second part of the question. Generally 2 marker, 3 marker, any question that can come. Differentiate conductors from insulators on the basis of band theory of solids. So let's see band theory of conductors: overlapping partially filled bands, large separation between the bands, energy gap 0 or very small, very large greater than 5 electron volt, charge carriers, abundant free electrons in the conduction band, very few or no free electrons. Okay, conductivity very high, conductivity very low. Any 2 or 3 points based on the question number is sufficient. Distinguish between p-type and n-type semiconductors. Doping element, trivalent, that is boron, gallium. Okay, n-type is pentavalent, that is phosphorus, arsenic. There is one more example, is aluminium is also trivalent. Majority carriers holes, majority carriers electrons, minority carriers electrons, majority carriers holes. Okay, charge movement due to holes, due to free electrons. So you remember that most of the students generally write these two holes, electrons holes. You have to use this should be your first point. This should be your first point, that is what type of doping element you are using. Okay, now next question. Write the 3 postulates of Bohr's atomic model. Let's see the 3 postulates. An electron cannot move round the nucleus in all orbits. It can move only in certain discrete discontinuous orbits. Okay, the permitted orbits are those in which the angular momentum of the electron is an integral multiple of h by 2 pi, that is mvr equals to nh by 2 pi. When the electron moves in these orbits, energy is not given out. Energy is given out only when an electron from a higher permitted orbit jumps down to a lower permitted orbit. The difference in the energy is emitted in the form of radiation. E1 minus E2 is equals to h nu. Write 3 limitations of Bohr's atomic model. The Bohr's model is applicable to hydrogenic atoms only. It cannot be extended to even to mere 2 electron atoms such as helium. Okay. While the Bohr's model correctly predicts the frequencies of the light emitted by hydrogenic atoms, the model is unable to explain the relative intensities of the frequencies in the spectrum. So spectrum is not uniform, some are brighter, some are less brighter, but why they are so, that is not been able to explain by the Bohr's model. The model does not explain the fine structure and splitting of spectral lines observed under the magnetic field, Zeeman effect, and electric field called Stark effect. Zeeman and Stark effect are two very important things that Bohr's model cannot explain. Okay, basically you can mention that he cannot explain Zeeman's and Stark effect, that is fine. Okay, how is total energy of an electron revolving in an orbit of hydrogen atom related to the principal quantum number of the orbit? What is the significance of the negative sign of the expression for the total energy of the hydrogen atom? So the formula is En is equal to 16 by 13.6 eV minus n square, and the negative sign indicates that the electron bound to the nucleus, to free the electron we need to provide equal amount of energy to the electron. Okay, so for example, if you want to free an electron which is located at n equals to 1, so what is the energy? Energy is 13 minus 13.6 eV. Okay, the unit is eV. Now if you want to free this electron, how much energy you have to supply? You have to supply 13.6 eV. If you supply this much energy, the electron will come out of the nucleus and it will be free. Find the energy equivalent of one atomic mass unit, first in joule and then in MeV. Okay, I will just use the formula and I will show you how to do it. Final calculation you can do it using the calculator. Okay, so one U is given by 1.6605 into 10 to the power of minus 17 kg. Electron is 1.602 into 10 to the power minus 19 C, and C is 2.9979 into 10 to the power 8 meter per second. So energy equivalent to one atomic mass unit means E equals to delta M C square. So what you are doing, you are destructing this much mass and you are trying to find the energy. So first is obviously in joules. When you are calculating in joules, basically what you have to do, you have to multiply all this constant using the calculator. So 1.6605 into 10 to the power of minus 27 into C square. C square is this, okay, 2.9979 into 10 to the power of 8 whole square. Okay, this will be in joules. Whatever value you will get, that will be in joules. Okay, I don't remember the exact value, but after that you have to convert it into electron volt, that is mega electron volt, that is entire value whatever you have calculated over here, okay, into 10 to the power minus 27 into 2.9979. you are allowed to use simple calculators in the PU board exam. So you can use your calculator to calculate it, divided by charge of an electron. Okay, that is the electron volt. So joules divided by charge of an electron is the electron volt, 1.602 into 10 to the power of minus 19, which will be very close to 931 MeV. This is a very common value. We often use it in our numerical questions. So one atomic unit is basically 931 MeV. Sometimes we round it off to 930 MeV. That is also fine. Okay, but you have to do this. This is a very simple numerical. Often asked, one numerical is very commonly asked from the chapter nuclei. Okay, define binding energy and mass defect. Write the relationship between them. So difference between mass and nucleus and its constituent is called delta M, is called the mass defect, and the relationship between the mass defect and binding energy is EB is equal to delta MC square. Expression for delta M is equal to number of protons into mass of the proton times number of neutron, this is number of neutron, into mass of the neutron minus total mass of the atom. This is the formula delta M. Now next question, write the three features of nuclear force. Another very common question. The nuclear force is much stronger than the Coulomb force acting between the charges or the gravitational forces between the masses. The nuclear force between the two nucleons falls rapidly to zero as their distance is more than a few femtometers. Okay, the nuclear force between neutron-neutron, proton-neutron and proton-proton is approximately the same. The nuclear force does not depend on the electric charge. These are the features of the nuclear force. Now let's see the last question. This is also very commonly asked question. Again I will give you how to solve it. You can do the mathematics and tell me the answer in the comment below. This is the last question. So calculate the mass defect and binding energy of N714, given that the rest mass of the nitrogen nucleus is 14.00307 U, rest mass of the proton is 1.00783 U, and the rest mass of the proton is 1.0086. Now binding energy per mass defect and binding energy. Now sometimes they ask binding energy per nucleon also. First we will find the mass defect. So what is the mass defect? Delta M is equal to Z MP plus A minus Z Mn minus capital M. Right, what are these numbers? This is the number of protons. Number of protons is given by this number, that is 7 into mass of proton, that is 1.00783. okay, if you wish to you can calculate them separately as well. Now what is A minus Z? A is 14, Z is 7, so 14 minus 7, what is Mn? Mass of the neutron is also given, 1.00867, okay, minus mass of the atom, which is given this 14.00307. The unit will be obviously atomic mass unit. This is the mass defect. Whatever value you will get, some value you will get, that is basically 0.121 if I remember correctly, but that might be, I might be wrong. So that will be the mass defect. Okay, now after calculating the mass defect, you have to calculate the binding energy. Now binding energy, you don't need to do much of this. What you have to do, you have to whatever binding energy mass defect you have calculated, you have to multiply with 931 MeV, that is the binding energy. We already did that part in the previous problem, so just multiply them and calculate what is the binding energy. Okay, and if you face any difficulties, don't forget to mention that in the comment below. So I hope you enjoyed this session, which is very short, crisp. In this 1 hour 20 minutes 1 hour 15 minutes long video, entire 2 marker 3 marker section is covered, so you can score 25 marks closing your eyes if you watch this video fully. The PDF of this video will be available in our channel, so if you have not yet subscribed to our WhatsApp channel, don't forget to join our WhatsApp channel. And if you have not subscribed to our channel, then definitely you have to subscribe to our YouTube channel, right? So with this note, I am closing this video. Soon I will be coming back with passing package. Till then, bye.